All right, today's lesson um, is going to be very explicit in terms of I'm going to show you some steps that you have to do to learn how to solve quadratic equations by a method called completing the square. Now, we just practiced this, and on Friday you got the lesson, you practiced it. On Monday, I showed you all the solutions where we were factoring perfect squares. Perfect square trinomials. Let me show you one of those. So, for example, x squared plus 8x plus 16, and we learned that you could factor this x times x, and the 16 was a 4 times 4, and then positives to give you the positive 8 in the middle. This 4x and 4x would add because they're like terms, and that was a perfect square trinomial. And if that perfect square trinomial was equal to something, for example, 8, then at that point we could use the square root method. We could square root both sides, and we could solve this guy. And I'm not going to go through all the math for it. Oops, root 2 that would be. But we could come up with our two solutions using this square root method. Now the problem is with this method is unless this was already a perfect square trinomial, so you could factor it as this perfect square, then you couldn't use this method. So today what we do is what's called completing the square, where we force that left-hand side to be a perfect square trinomial, then we can factor it into this perfect square, like so, and then square root both sides and solve it. So this is important for two reasons. The first reason is we can, three reasons. First reason is we can solve quadratics this way. It's not a very good way to solve them. The second method, though, is it helps us put it into vertex form. So we could graph a quadratic very quickly, find its minimum, its maximum, depending on the case, and whether it opens up and down and so forth. And then the third reason is it helps us develop a general method for solving all quadratic equations. So it's very important in the development of your mathematics. So let's take a look at a few problems and see how we would get them into these perfect square trinomials so that we can solve them. Previous screen, what we mean by completing the square is taking a trinomial and getting it to be a binomial times a binomial, something that is squared. If we can get it into this form, then we can use the square root method and solve a quadratic equation. 16. We just saw this in this little previous example. That thing is now the perfect square. So let me walk you through how we complete the square on a quadratic equation. Now this is in standard form, okay? So it's ax squared plus bx plus c. So when I refer to a, I'm talking about the number that's in front of the x squared. In this case, it'd be a 1. When I refer to b, I'm talking about the number in front of x, in this case 8. And when I'm talking about c, and c I will refer to as the constant, doesn't have an x with it, that would be the 5. So what we're going to do is try and solve this by completing the square. Again, jumping back to without this method, this would be a very, very difficult problem. So rather than erase, I'm just going to rewrite this. So there we are. So here's your first step. And this will be the first step every single time. take the constant term to the right of the equality sign. Okay, so in this case, the 5 is on the left. If you think about this equal sign as having a left side and a right side, we want that constant term on the other side. So you're going to do that first. And that'll leave us with x squared plus 8x equals -5. Okay. Second thing you're going to do is you want to make sure the coefficient of x squared, the quadratic term, is a 1. Okay, in this case, if we look in front of the x squared term here, there's no number shown, but that's an implied 1, so it's 1x squared right there. It can't be 0, it's got to be a 1. If that was 0, that wouldn't even exist, and it wouldn't even be quadratic. So you have to have a 1 there. We just don't show it. So that's already completed for us. Step 3, you're going to have to memorize this. -b over 2 squared added to both sides. So let's find out what b is. Now remember, b up here at the very beginning I said was right next to the x. So here's what b is. It's right next to the x. So b is an 8. So let's calculate that real quick here. Well, with the opposite of b, now b is an 8, right next to the x, over 2. So with our little formula here says squared. And what you want to do is simplify that fraction first. So -8 divided by 2 is -4. -4 squared is 16. And it says added to both sides. So now let's add it to both sides. So here's how it looks. X squared plus 8x plus, I'm adding that 16 now, equals, I've got -5, and I'm going to add a 16 to the right. And you got to add 16 to both sides, otherwise you don't stay balanced. But at this point, you essentially have completed the square. And I'm just going to say factor and simplify. Let me show you the factoring. See this left-hand side now? By adding that -b over 2 squared, you've made it x squared plus 8x. So we didn't have this in the original problem, but by adding that 16 to both sides, it can now be written as an x plus 4 quantity squared, and the right-hand side does whatever it does. -5 plus 16, that's 11. And now we can use the square root method. You have completed the square by adding that 16. Square root both sides, and we can now solve it. X plus 4 equals plus or minus root 11, and x equals, take the 4 to the other side. So we subtract 4. We have just found the two solutions to that quadratic equation that we started with by completing the square. Now this is a very tough lesson to actually learn online and even in person. I'm going to run you through a couple more examples, and then hopefully you'll be able to follow it. So in this next example here, I've got a quadratic. It's equal to 0. Step number 1, I'm going to take the constant to the other side. And the nice thing is, everybody, this is a nice formulaic method. Just take the constant to the right. Okay, so here's our constant right here. It's this 8. And so how do I move them to the right? I subtract 8 subtract 8. And I end up with x squared minus 4x equals negative 8. 0 minus 8. Second step, I got to make sure the coefficient of x squared equals 1. So I just look at it and go, yeah, in front of the x squared there's just a 1. I'm good. Step 3, negative b over 2, and I square it. I'm going to put the work right next to that statement right there. So here's my b term. My b is negative 4, so it's going to be negative, and here comes the b. The b is negative 4 over 2, and then squared. So that double negative right there, that's going to give you a plus 4, so 4 over 2. That's 2 squared, and 2 squared is 4. So 4 divided by 2 is 2, 2 squared is 4. 4 is this number that I have to add now to both sides. And that's part of step 3. Add to both sides. So here we go, we're going to add that. So I've got my x squared minus 4x. Here I'm going to add that b over 2, quantity squared, to both sides of the equation. And that's really the key part, that negative b over 2. And once you've done that, that left-hand side, every single time, is going to factor into a perfect square. I'm going to show you that full factorization so you can see it. X and x gives you the x squared. 2 times 2 gives you the 4. And the negative 4 becomes, because of that and this, that outside product and inside product. And so we have made the left-hand side a perfect square. The right-hand side, you just do the math. Negative 8 plus 4 is negative 4. And now you're ready to use the square root method. X minus 2 equals plus or minus square root of negative 4 is 2i. Remember, when you square root a negative, you get an I. And we add 2 to both sides to get rid of it here. 2 plus or minus 2i. You just found both solutions to this original quadratic. In this last example, this one's a little more complicated. Oops. What the heck did that happen? There we go. I'm going to write down, I'll just explain the steps as I go through, and I'll try to make it as simple as I can. Again, these are very tough problems, but I know y'all can do them. So step 1, I'm going to take the constant to the other side. Okay, that's the negative 6. So I add 6 to both sides. Watch what happens. X equals 6, like that. So I've just gone plus 6 and plus 6. Here they knock each other out. So that's step 1. Constant to the right. Now comes step 2. Coefficient of x squared equals 1. Now this one's a little bit different. Notice the coefficient here in front of the x squared is a negative 3. I don't want that, so I got to get to be a negative, or just a positive 1. So I'm going to divide everybody by negative 3. And I'll get x squared, negative 3 divided by 3. I'll get a plus 6x, and I'll get a minus 2. Man, we're in good shape now. All you have to do now, this is the easy part. We just have to remember it. Take that b term. This is step 3. Take the b term, divide by 2, and square it. 6 divided by 2 and square it. That's 3 squared, which is 9. And that's what you want to add to both sides of the equation, so it becomes x squared plus 6x plus, here comes that number I just added, 9, equals -2, and I have to add it to the other side to make it balanced. As soon as you do this part, this step 3, the left-hand side is a perfect square. X plus 3 squared. See that 9 right there is a 3 squared. And if you were to take x plus 3 times x plus 3, this is what you'd get. The right-hand side does whatever it does. In this case, -2 plus 9 is 7. But see, this left-hand side, rather, is a perfect square now, so you can just square root it. And so we just go, alright, square root. So x plus 3 plus or minus root 7. Take the 3 over, and we have two answers for the quadratic. -3 plus root 7 and -3 minus root 7. Alright, that's it. We'll discuss questions tomorrow. This is a very tough section. So we'll have to make sure we cover some questions in class as we go through it.